everybody, welcome to our session. It's great to see so many of you who have already joined, and those of you still joining, welcome. I'm pleased that we have two distinguished guests with us today. We have Emel Akhtas from Cranfield University and Mike De Temple from Anaplan. So welcome Emel and Mike. And both Mike and Emel have great knowledge to share with us today about supply chain analytics. So I'm really looking forward to this session. And I think I know in fact that all three of us have a strong feeling that with a better understanding of supply chain analytics, and also if we had great analytics built directly into our planning tools, that we could and should be doing a lot better than we are today generally with supply chain analytics. And we think the AI, ML and data science movement has really shone a spotlight on this. And I think with the attendance today, you can actually see that a lot of people are showing great interest in this area. So pleased today that we'll actually be discussing many of the important techniques and the application of those techniques with you today. So what you'll learn today, the takeaways for today, will be understanding and explaining history, even if maybe right now history is probably the worst time ever, the worst time in history ever as a guide to the future, but there you go. We'll also be talking about how to apply analytics to inventory management to optimize inventory policies as much as possible. And also maybe how to enhance the fairness of performance measures by using analytics. You know, where should we be performing well, and maybe what's more difficult to forecast, and maybe where we should not expect such great forecast accuracy. And throughout, probably some of these techniques are misapplied or misunderstood in a lot of use cases. And throughout, we'll have a focus on how to apply these techniques to trend and seasonal products, which is a real complication in the application of some of these techniques. So to the introductions, first let me introduce Anaplan. So Anaplan is a planning platform. It's a cloud-based planning platform. So I guess Anaplan is to planning what Salesforce.com is to sales, or Workday is to HR. And Anaplan's quietly leading a planning revolution on the web. Veralta, we're a global Anaplan partner, and we develop, so I guess all we do is Anaplan, so we consider ourselves Anaplan experts and planning experts, and we do all areas of planning, but I actually lead the development of the supply chain applications on the Anaplan platform, but you can also use Anaplan for any planning use case. And Cranfield University, for those that don't know, Cranfield University is the #1 ranked supply chain university outside of North America. So in terms of our speakers, I'm very pleased to introduce Emel. So Emel is Professor of Supply Chain Analytics at Cranfield, and Emel extensively advises us on the analytics in our supply chain applications. Mike De Temple is Senior Director of Supply Chain Solutions at Anaplan, and he helps shape the go-to-market strategy for supply chain solutions at Anaplan and works with Anaplan customers. And I lead the supply chain application design and development at Veralta. So the agenda today, well, the format, first we'll do an intro. We've just got 3 or 4 slides. Mike's going to set the scene on, you know, where the software world is with supply chain analytics. Emel's going to set the scene on where the more academic world is with supply chain analytics, maybe. So that's just 4 slides. So we're just going to do 4 slides to set the scene on where we think analytics fits in today's world. We're then going to tackle 6 of the most frequently asked questions, maybe the 6 most difficult questions. And hopefully we'll still have some time at the end. So as we go along, please put your questions in the Q&A or the chat box, and we'll try and pick up your questions at the end in an open discussion. So we do have a couple of slides through the way to guide the questions, but it's going to be mainly discussion focused. There are screenshots of the apps throughout, so when we want to demonstrate a technique, and it's not going to be a live software demo, but if there are any discussions where jumping into the live software could aid the discussion, then I'll do that. I'll just flip into Anaplan and our apps sitting on the Anaplan platform and show a couple of ways potentially to apply these analytics. So that will be the format for today. So moving on to the introduction, and I'll hand over to Mike.
Thank you very much. And I do want to thank you for inviting me to participate today. Although I'm a panelist, I think I'm here as much as the rest of the audience is to learn from the discussion that we're going to have. As Anthony mentioned, there's tremendous interest right now in analytics, no doubt. And this has really been growing over the past, 10 to 15 years. It really started obviously with with the birth of the internet and the ability to connect our world in a far more granular way. Combining that with very cheap cloud storage means that more data is more accessible than ever. Many of us lived through the first wave of the big data hype that happened in the early 2000s. But we're seeing a few other trends culminate right now and really drive more interest in analytics. One is we already had cheap storage, but now we've got cheap compute capabilities, whether it's AWS or Google or Microsoft, the ability now to not only store large amounts of data, but to run very efficient calculations against those means that more data plus cheap compute gives us better analysis, or if not better analysis, certainly ability to do analysis at scale. And now, obviously, the hype of the day with emerging new tools, whether it's in the areas of AI and machine learning or other more sophisticated analytical techniques, this combination of more available analysis and more sophisticated techniques is really driving a huge opportunity for us to leverage analytics. And for those of us that have spent their careers in supply chain, there's probably no better area in the enterprise today to leverage analytics to drive really effective outcomes. Thanks. You can jump to the next. So what has held us back from really leveraging analytics more effectively? I'm a little bit old school. I come from the days when we called it decision support. We didn't talk about analytics or any of the other new terms. I still like that old term because it really puts the emphasis on making a decision. Planning and analysis should really drive you to make better and more effective decisions. But the typical planning process and experience really isn't all that cohesive. There's still a lot of friction between data and analysis, generating insight, and then actually taking action. We struggle to generate insights in general for many reasons. In some ways, there's a lack of talent as the analytics has become more sophisticated, as the data science boom has really dominated a lot of interest in the market. Finding individuals with the right skills to bridge technical analytics and effective decision making, it's becoming challenging. And despite the availability of great amounts of data, the quality of that data, the provenance and management of it is continuing to be a challenge. And finally, there's the cost and complexity of deploying effective analytical solutions and deploying them in a way that supports your planning processes, which gets us to the other side of the equation, which is consuming those insights and taking action. Some of the barriers there, and probably the biggest one, are that effective analytical tools and effective analysis today still tends to be very siloed. It's the provenance of a data science team or a tool that is perhaps specialized for analyzing data, but the reality of the individuals on the ground is they're operating within different planning systems, and that's where they need to take action and make the decisions to actually affect what's going on in the supply chain. And bridging that gap between the analytical insights and your ability to put those into action it continues to be the primary challenge. And the other element is somewhat of a lack of trust in the analytics themselves. As we've evolved in the direction of having more sophisticated analytical engines underlying our software, there's been a tendency to make those black box decision-making engines. There's an element of just saying trust the algorithm or trust the output. But in a world that we live in today where things are highly variable and the output of that analysis can change from day to day and week to week, the ability to understand at a granular level what is going on and why certain insights are being driven is critical for the planner to trust the process and effectively put those things into action. Can you jump to the next one, Ann? Which brings us to Anaplan, a very brief pitch here on how we see the world and how we're trying to allow individuals to make more effective decisions and make them quickly. The key thing is that we understand that everything is constantly changing. There's never enough time to do deep analysis. There's too much data to look at, and the timeframes that we're given to analyze and then act are compressing. Combine that with a world right now where, as Ann had mentioned, trusting history is problematic in the very least. What we're focusing on is making sure that the platform on which companies do planning, in our case Anaplan, has analytics embedded in such a way so that they are intuitive and intelligent and easy to apply within the planning process. Some of the ways we're doing that, PlanIQ is our framework for accessing really best-in-class AI and machine learning-based forecasts, but exposed to the user in such a way that you can embed them where needed in your planning process and do it in a way that's very easy to both set up and very easy to consume the output, but without requiring you to be an expert data scientist to go in and tune the algorithms and figure out how to make it all work. We also have an application called CloudWorks, which is a capability within our platform to allow you to go outside of Anaplan and leverage the investments that many organizations are making in Amazon, in Google Cloud, and elsewhere, where you may have data science teams that are leveraging some of these very powerful tools, but are struggling to take their proofs of concept and their research projects and deploy them effectively into day-to-day planning. That's where CloudWorks allows you to easily connect to those data stores and connect to those external algorithms and bring them into your overall planning solution. And ultimately the idea there is to make effective analytics easy to deploy, easy to understand for the end user, and put the control back in the hands of those who are actually running the planning processes, rather than having to trust software developers and others to do the right thing behind the scenes. We firmly believe that you need to expose this stuff to the users in a way that allows them to really complement the planning process that they're supporting and complement the insight that they as individuals bring to the process. Great, thanks. We can move on from there.
Great, thanks for those insights, Mike. So, Emil.
Yes, and what I will contribute to this discussion is the understanding of uncertainty and variability. So we have certain understanding of the demand and how it varies, and we can prepare for that seasonal variations, for example. But then there is the uncertainty associated with many phenomena in the world, including the sales patterns of our products. And what we are trying to do with the use of these tools is separating what we can predict, separating the variability that we can predict from the variability that we have to be prepared for in terms of safety stocks, for example. So going forward, we noticed that we are talking quite comfortably in averages, but talking about the average without the standard deviation, without how much variability there is in that demand series is incomplete. So for example, on the top right panel, you see a blue shaded bell curve and a red shaded bell curve. And you can see they both have the same average. But the variability in the blue shaded curve is much wider than the variability in the red shaded curve. So I can be prepared for the variance in the demand with much lower safety stocks for a demand series that follow the red one compared with a demand series that looks like the blue one. So we always need to take into account how much variability there is in the demand series when we do prepare our plans to match the demand with our supply. There is also the element of uncertainty becoming much more increased as we try to forecast wider into the future. So it's always easier to forecast a few days from now, a few weeks from now, compared with several months or years from now. So we have to incorporate that uncertainty associated with the forecasts that we are producing, and building these confidence intervals around the forecast variable, so that we have an indication of how variable the forecast itself is going to be going further into the future, several weeks, so on and so forth. So the main idea these type of platforms carry is that we have the demand series, and this is a time series information. Currently, it's only focusing on the time series and decomposing it into a baseline series coupled with a trend and a seasonal element. So with the mean, with the average, with the trend and the seasonality, when we decompose a series into these elements, we are left with a randomness that we should be prepared for in our safe stock estimations. So that's the key idea, really. So without really incorporating too much additional information, looking at the time series, what has happened, and projecting into the future, considering the uncertainty associated with the forecast, and pulling out the predictive variability, the mean, the trend, the seasonality, so that we can have accurate forecasts.
Great, thanks, Emma. And I think it's this decomposition that really helps us to handle trending and seasonal products and apply the standard techniques to trending seasonal products, isn't it? It's understanding these different elements and not just taking the average, but first understanding if there is some seasonality and if there's some trend, because we can understand that and we can predict that. And just be left with the true randomness that we need to manage with safety stocks. And we can apply this to performance measures as well. So before we jump into the first question, did you have anything to add, Mike?
Just one statement, and we're focusing a lot on traditional statistical techniques and decomposition here, but the same concepts apply as you begin exploring machine learning based forecasting algorithms, where you can bring in additional external causals, external features that you wish to explore. And you can begin decomposing your forecast now, not just into base, trend, and seasonality, but understand the contribution of things such as pricing and promotions, socioeconomic, demographic, macroeconomic data, and a lot of other great features to enhance your forecast even further. But the great thing is all the fundamentals that we're discussing here today underlie the application of even more sophisticated algorithms.
And I think that's a great point, Mike. And I think it all comes back to being able to distinguish which is variability versus which is uncertainty. Because if we can explain the variability through weather, through price, through short-term actions or long-term trends, then it's not uncertainty. And I think that's really where the more variables we need to understand that variability to remove uncertainty is where the power of data science and machine learning comes in, right? So, right, great. So we've now got the 6 FAQs and we'll take the open questions at the end. So we'll just go through these. So the first question we have is, how should you perform history correction for trend seasonal products? So I'll let Emel go first on this one.
So in terms of the history correction, so this is a frequently applied method on the time series, and we tend to observe significant deviations from expectations. So you can see on the slide with the red bar cutting the top of some extreme values. So the main idea is to understand whether we need this history correction, why this deviation has happened. Maybe it was a promotion or it was something else that we do not expect it to repeat in the future. So if this is such a deviation, we will have to perform a history correction and run our models on the corrected history.
Okay, thanks, Simon. Did you have anything to add, Mike?
No, I would say though there was a question that came up in the chat that that underlies some of the foundation we just set up, which was, can we say that trend and seasonality are linked together to some extent for goods, like ice cream? And I'll certainly let ML as our expert jump in on that further. But the short answer is no. The trend and seasonality should be independent of each other. The algorithms themselves that decompose the forecast into trend and seasonality are designed to tease out the difference between the two. In the near term, it's often difficult to understand whether an increase, for example, in demand is a seasonal event or something that is a real shift in the underlying trend, which is why multiple years of history are typically used in order to allow us to effectively decompose those two.
In fact, I can jump into the software right now and actually show decomposition. So why don't I do that to explain this concept? I think this is a great use of where jumping into the tool brings actually this discussion to life. So what you can actually see at the top in the tool, it's the system's telling me that if I use the pure mean, I've got a very variable data set. Even if I take trend into account, I've got a very variable data set. But if I can take the trend and seasonality into account, I've got a much less variable data set. So this is removing the known variability to leave us with the true randomness in the decomposition. So this is pure decomposition. So basically what the system does, the first thing it does is you can see this is the history over several years, over 4 or 5 years. The first thing the system does is it plots those year over year. So actually the system doesn't need to do this. This is to give us a good visual so we can understand what the system's doing. And what we can see is the system can depict that there's some underlying seasonality in this demand pattern. This could be because of Christmas, this could be because of ice cream in the summer, but this is the standard repeatable seasonality. Once we remove that from the system, well, the next thing the system does is take the average of those and create a seasonal index. Once we remove the seasonality from the system has then identified there's an underlying trend. And what's really important is because this is such a seasonal product, if I go back up to the pure history, it's not actually really that noticeable that there's an underlying trend going on in this product. But if I go down, once I've removed the seasonality, I can see there's a very slight underlying trend. Well, it's not that slight, slightly significant underlying trend even. And then once the system's removed both of these from the data set, then you're left with the residual, which is the variability that can't be explained by trend and seasonality. And traditionally, this is what we've been left with. And I think part of what we're trying to do with AI/ML is to be able to understand some of this more. This could be because of the weather in short term, which you can see in the Amazon forecast for short-term weather patterns. It could be because of pricing. It could be because of competitive actions, just where we need more data than the pure history to understand some of this additional variability. So that is actually the basis for history. That is the basis for a lot of what we do today. So I'll just touch on history correction quickly. So if I just, this is the same data set. So if I say, well, there's a lot of questions around history correction, but if I just stick to the basics, should we even do it, right? But if I just stick to the basics, how not to do it. So what you shouldn't do, and maybe where it gets a lot of bad press is, if I've got a clearly trendy seasonal product, what I shouldn't do is correct history by X standard deviations from the mean, because what you're going to see is I'm going to correct my historic peaks, which clearly are going to repeat every season. So this is probably not the best way to do it. even if I correct from the trend line, which I do now, you'll see that that's not enough because the trend is quite slight. So my now correction is taking account of the trend. So clearly for this product, I need to correct, taking account of trend and seasonality. So what I've got on the graph in the black is my corrected history, in the gray was my original history, and the red lines are the upper and lower limits for correction. And I can control how tight I want to make these bands as well. So let's say I pull them into one. Yeah. Oh, yeah. That wasn't supposed to happen. But if I pull them into one, if I pull them into one, the bands would get narrower. And what I would actually do, the graph you didn't see, if I would have clicked the corrected trend seasonal there, instead of doing this correction, the system knew from the decomposition it had undertaken the expected trend and seasonality profile. So instead of having these straight line bands as the upper and lower limit, the upper and lower limits would have followed the expected trend and seasonality. And we would be looking for deviations outside of that expected trend and seasonality. So that's the first thing really is, should you apply history correction? There's a debate there, but how not to apply it is probably as important, is don't apply it using a mean or a trend if you've got a seasonal product. Before we move on to the next question, did anyone have any other comments?
I can comment on like where we apply this type of corrections, specifically for promotions. You expect the demand not to increase seasonally, but maybe forward buying induced by the promotions from the customers. So then we'll have to use some kind of intelligence to understand that this was due to promotions, but it wasn't seasonal. Hence, we don't expect such an uplift unless there is another promotion. So that kind of informs promotion forecasting type of activities rather than baseline trend seasonality based forecasting.
Yeah, I think promotions and price changes are definitely, and competitor actions definitely can help us with the history correction process. And not having that information is why sometimes I think people see it as a naive process. So I guess that leads us nicely into the next question, which is, how should you identify real changes in trend versus plain old variability or seasonality? So how do I know when something's actually changed and I need to start thinking about a real change in the demand pattern for one of my products? Emel, do you want to lead on that one?
Yes, with pleasure. So we'll have to see as a systematic increase in the expectation from the actual forecast, for example. If we were to have a look at the forecast, and if we see that we are constantly being behind or constantly being over, that suggests that the trend has changed. So we can use techniques such as tracking signals, that we are constantly outside the upper bound and the lower bound of the expected variability that is coming from our models. So if our model is constantly under predicting or over predicting, that suggests that the system has changed and we need to update our parameters.
Mike, did you have anything to add?
Yeah, I think the key thing to recognize is that this is always a lagging indicator. You're going to go through several periods of actuals versus forecast before you can even identify that your current forecasting model is perhaps drifting and no longer matching reality quite so well. So the key here is to have these tracking indicators in place that you do monitor regularly as part of the standard process, so that you can identify things shifting in, not in real time, but as quickly as possible, and begin investigating to understand what may have shifted in the underlying data that might be causing the forecasting model itself to begin drifting and exhibiting some things like bias, where your forecast may undershoot actuals 3 periods in a row, 4 periods in a row. you need to be tracking those key metrics so that you can identify the shift and dig a little bit deeper.
Mhm. Yeah, and I guess it kind of goes almost into demand sensing, and I think demand sensing is being applied to lots of things that maybe aren't demand sensing. But one way to try and identify these trend changes, we do have building our apps on the Anaplan platform, and this enables you to choose a period of analysis, as in this example. And basically the red lines again are our upper and lower limits derived from the decomposition. So this is what the system would expect demand to be. And then we can look back over a period of time and see, and what we're looking for is constant breaches in a direction. Now you can see I actually do have 3 small breaches outside of this zone. So the system's telling me they're 3 up. And if I just expanded my limit a little bit, I wouldn't have any breaches. We can see this is actually closely following. But if all of a sudden the history started moving up here or down here, I would quickly see that I've breached these limits within a few weeks. And just pure history can give me an indication therefore that something's changed. Another technique, I think, is to compare if, as Mike said, to compare if we're constantly breaching forecasts, where what do we do when history isn't a good guide? Well, if we have a forecast, we think that should be our best guide to the future. If we're consistently breaching that forecast one way or another through a bias measure or whatever, then we can go and investigate if something's happening. Now, bias may just be indicating that there's some systemic trend or bias towards over or under forecasting in the organization. So that obviously needs to be dealt with as well. So, are there any other comments on that, Michael and Mel, before we move to the next question?
No,
we can move on.
Yeah.
Great. So this is a great one for me. I remember I left Cranfield a few years ago, and I was all excited about how I was going to apply my learnings in the industry. And the first industry I was in was actually, there was quite a lot of seasonality and trending. And this actually made the application of the standard safety stock formula somewhat challenging. So most software packages do enable some kind of dynamic safety stock setting, but it's rarely adopted and rarely applied. So I guess one of the key questions is, should we really trust the standard safety stock calculations to guide us in setting safety stocks? Mike, should we start with you, Mike, this one?
Yeah, I think we highlight some key things there on the right, which is in order to get the math to work for a lot of inventory calculations, we've made some fundamental assumptions that don't always match with reality. Normal distributions make the math easy, but we know in supply chain that many of our items, particularly when you're looking at a granular item location level, are not normally distributed. We also understand that things aren't stationary. Demand and the demand variability does shift over time. But that shouldn't stop us from leveraging analytics like this to make better decisions. It's countless times I've worked with organizations that had applied, the standard rules of thumb, such as we're going to hold, 7 days of inventory. And they applied that broadly across all products or across the broad categories. There is a tremendous opportunity to get better over time by applying some of these methods. And the ultimate arbiter is, how are you doing on your service levels, your ability to fulfill orders at what inventory level? And if you're able to apply these techniques and show that inventory is decreasing while service levels are maintained or increasing, you're doing the right thing. Even if you accept the fact that the calculations themselves may not be perfect. It does keep you driving in the right direction. And as you look at it across a family of products, it does help you hone in on which ones require more attention and which ones perhaps are behaving well. And that's really the intent here, is to allow the inventory analyst to focus their attention where they need it and address the issues as they arise.
Thanks, Mike. And Mel, do you have any comments on this one?
Just to add the distinction between the safety stock, which is based on the standard calculation is based on the cycle service level. So it's like out of 100 cycles, how many of them do you expect to stock out? And it's a rather conservative measure. As Mike has said, it's assuming normal distribution, where we know many of these areas are not normally distributed. And then there is the concept of fill rate. So if we are talking to companies that the fill rate overtakes over how many periods I expect not to stock out, because it's always better to fill proportion of the demand and look at how well we have done in terms of that, which is the fill rate, versus how many cycles we were able to satisfy the demand from stock. So we tend to observe fill rate being used much more often than the cycle service level, which is a probabilistic approach to safety stock calculations. And the other thing to add here is the number of echelons that we see also on the slide. So we have a network, we have branches, we have distribution centers fulfilling the branches or stores. So can we look at the inventory investment across the network, not just individual places? Because if we were to set the safety stocks based on just the individual stores, we tend to end up with much higher inventory across the entire network than the case if we were able to incorporate the inventories in echelons.
Yeah, totally agree. Thanks, Emma. Yeah, so I think we're actually working on a white paper at the moment, aren't we? Where we actually look at the standard safety stock formula versus, so I think one of the key questions is it better than what we do today? So if we take a single echelon network and compare a broad 3-week supply or 2-week supply inventory policy approach to the standard safety stock formula, the standard safety stock formula massively outperforms. However, we know there are some weaknesses with the standard safety stock formula. So there's some caveats to that. I think one, it doesn't necessarily outperform on a multi-echelon network because there are some complications there. So we need to adjust the safety stock for the multi-echelon network and do more simulation and algorithm there. And then also, I think where it gets a bad name, I think these two graphs show the case in point. We have to be inputting the right measure of variability into the safety stock calculation. So the first graph shows pure demand variability as the input to safety stock calculation. And we can see we're carrying a lot of safety stock. And with a high forecast accuracy of this trend seasonal product, because we've done forecast decomposition, we just don't need this much safety stock. And the standard safety stock formula gets itself a bad name. However, if we measure the forecast error or the residual variability once trend and seasonality is removed, we get a much lower safety stock for the same demand pattern. And this is much more realistic to achieve the service levels. The other thing we've worked with Cranfield a lot to do is to bridge this gap. Business doesn't talk in cycle service level, it talks in fill rate. So we do that conversion between the two in the software for you. So I think there's some of the big points on safety stocks. So Emel, I think question number 4 is for you, as this is your table, and I think I'll bring it up for you there.
Thank you very much.
So how should we measure forecast accuracy? Should MAPE, WMAPE, RMSE, bias, with lots of these measures going around. So which is the true measure of forecast accuracy we should be using?
Okay, thank you very much for the question. So we see on this slide different metrics that we would measure for forecast accuracy, such as MAPE, which is mean absolute percentage error, and it is a unitless measure. It is used for comparing forecast performance of different types of stock keeping units, for example. It is because it is unitless, then you can have a comparable metric. We also have here, for example, the root mean squared error. This is normally used to choose a forecast model itself. So on the same series, which model performs better, and RMSE penalizes the forecast models that are deviating too much from the actuals. And then there is also the concept of the forecast value add. So something to say about that. Traditionally, we we evaluate the performance of forecast analysts based on one of these metrics, for example, MAPE. And you see the traditional approach. We have three analysts here, A, B, and C, with different MAPE percentages. And the MAPE for A appears to be the lowest at 20%. But is this really a right approach to assess the performance of the analysts and assess the performance of the models as well? So we have a breakdown at the bottom part of the slide, which is introducing this forecast value added approach. So we tend to have the system, the software produce forecasts, and then analysts would override these forecasts. They would correct the forecast coming from the system. And you can see it in the bottom table that analyst A manages a basic product with a really long life cycle. The product is not seasonal, it doesn't go on promotion, it doesn't have too many new items introduced, and it has a low demand variability. So the performance of this analyst A is 20% MAPE. But when we compare it with a naive method, we see that the naive method has a lower MAPE. So comparing the analysts just on the MAPE they achieve is not sufficient. We should always compare it with a simple model, and we expect the extra effort to outperform the simple forecasting methods MAPE performance. So in essence, in the first line that is corresponding to analyst A, unfortunately, they do not really add value with their corrections to the forecasts. So the forecast value added is in fact negative here. They can't improve upon a forecast coming from the system. Whereas if we look at the analyst C, they are managing a fashion item with a short shelf cycle. It's highly seasonal, many promotions, many new items introduced, high demand volatility. And they have a MAPE of 40%, but that is better than the MAPE coming from a naive model. So in essence, although their performance appears to be not as good as the first analyst A, in fact, they do contribute. Their overriding of the system-generated forecast is adding value to the system. So the general suggestion is that we should ask analyst A to focus on something else that the system cannot forecast very well, rather than overriding forecasts coming from the system for products such as the one that he or she is managing, a basic long life cycle item. So I guess that's kind of the key messages I would like to give here. And also not to be obsessed too much about the MAPE. There are some products we can forecast accurately, and there will be some products we won't have too high a forecast accuracy. So we need to monitor how well we are doing on those items rather than having a ballpark MAPE to achieve or inachievable MAPE. I should conclude with that.
Mike, do you have any? I know this is an area of interest for you, and you have some feelings about this. So, do you have anything?
Yeah, I mean, it's a couple things to think of. One is when you're selecting your forecasting algorithm, you need some measure of forecast accuracy to help you understand which approach is performing well. It's very common to see one algorithm perform better on MAPE and another one performs better on a weighted MAPE or a mean squared error. So we always recommend you should consider multiple metrics. It's possible you might find one that performs well across all of them, but it's a little bit of a balanced scorecard approach. But that just gets you to your algorithm, which is one input to the process. I am a huge fan of forecast value add as a measure of overall process effectiveness, because it does help you focus your attention where your analysts can truly add value, and helps you understand where they may be hurting the process. And ultimately, we have to keep in mind that MAPE, in a sense, is inherent and so tightly tied to the forecastability of the product itself that comparing MAPE from one item to another, again, or one category to another, one analyst to another, in some ways is a waste of time. as noted here. Compare the process to a naive forecasting approach to help you understand where you're applying your overrides and your attention effectively. But ultimately, you need to measure the effectiveness of your process by looking at other KPIs, things like fill rates and inventory levels that are really the intent of the process. MAPE in and of itself is just one metric, but improving MAPE fundamentally isn't your goal here. Your goal is to improve the overall financial effectiveness of your supply chain and customer service effectiveness, and those are the metrics you need to keep your eyes on.
Great. Thanks, Mike. So I guess though, when we go back into business, I remember reading that we should have bands of uncertainty around forecasts, right? And then if you look at, I'm a secret meteorologist, right? So I know, that's the case. We say there's a 50% chance it will rain tomorrow. So we should apply the same kind of probabilistic certainties to our forecast, but that doesn't really cut it in business because everybody wants to find like a number. And we've talked about this amongst ourselves, and we think that's because the downstream processes and systems need a number. MRP wants a number to explode. It doesn't want a range and therefore give us a range of materials to acquire. Although we think this using simulation, we should do more of this, with supply chain digital twins and stuff like that. But the reality is lots of us will go back to our businesses after this session, and we have to have one MAPE. The board wants a forecast accuracy target and a forecast accuracy measure, and we want one forecast, and we don't want bounds of certainty around the forecast. So living in that world, if we do have to have a MAPE measure or a forecast accuracy measure, how can we make it fairer, or how can we make it more applicable? So one is to, the forecast value add, which is to try and beat the naive method or the best fit method from the stat engine. So in Anaplan, we measure what the forecast is versus the statistical forecast versus the pure demand plan forecast and this kind of thing. But applying analytics to this problem, one thing we can do is here, this is a screenshot from Anaplan. So on the left, I have the coefficient of variability plotted against total sales. And what you'll see is generally the higher my sales are in terms of volume, the less variable the demand is. And as I go down the tail and I have lower and lower volumes, generally the variability of that demand increases. That's just a pretty much trend. And I've plotted this in many, many businesses, and it nearly always looks like this. And you need to almost use a log scale on the graph to see the clear pattern. This is the graph on the right is actually the variability versus the error from a standard forecast engine. And again, as you can see, there's a clear line that as this variability increases, so basically as throughput decreases and variability increases, forecast accuracy or forecast error deteriorates. And we can actually see there's quite a straight line relation there. So if we can measure the C-var, or the true variability, which is the true variability divided by the average demand or by the mean, to get an indication of the degree of variability of that product, because the standard deviation by itself is not a relative measure. So if we know the standard deviation is 10 and the mean is 20, that has an average variability, say, of 50%. So given we know that that's inherently the inherent variability of that product, we can assign a more applicable forecast accuracy target. So we could divvy this chart up and say, well, if your C-var is less than 0.5, you need to be pretty accurate. And clearly, when you're dealing out with a tail of very, very highly variable products that we can't explain, your forecast accuracy target probably is lower, or your tolerance for error is probably higher. So there's Emel or Mike, did you have anything to add to that one? I kind of stole that one.
No, I think you've covered it well.
Very well.
So I'm going to leave the last one to you two. We've got 10 minutes left, and then maybe a few minutes on this.
We've got a lot of questions in the chat window as well.
Great. So, well, I'm not going to comment on this one. I'm going to throw this one to you two. So what happens? So this C-var tail where I've got really highly unpredictable demand, which lots of businesses are faced with, right? Massive long tail of SKUs, highly unpredictable demand, 004, 006. I cannot forecast it. What do I do?
So you see here a cumulative distribution graph. And the idea here is that if I can't forecast it, can I then look at the minimum and maximum inventory policies? So can I find that figure below which 95% of my sales were? This could be, for example, you have highlighted 95% interval there. Where does it cut? And the key messages here, as we have already talked about it in the previous slide as well, that we don't want to improve MAPE on its own. What our target is to satisfy the customers with the availability of our products. So what figure increases the availability of my products so that I can maximize the supply chain surplus? Maybe I can turn to Mike to add a few things to that.
No, I think that's exactly right. The layman's response would be, don't waste time forecasting items that really aren't unforecastable. Set inventory policies that can essentially run on autopilot. Sell one, replenish one is a very simple idea. And if you're running into availability issues, you know that your inventory level is not correct, and maybe you set it at 2. And so it becomes a little bit of an experiment simply to find the right level that maintains it. But asking some analyst to go in and improve a MAPE on that is just wasted effort when it could be spent elsewhere.
Yeah, this is an area, I totally agree, guys. But this is an area I see massive resistance. I must have done maybe 20 or 30 supply chain planning implementations in my life. And every time we get to this tail and we say this should be an inventory policy, it's no longer forecastable. There's massive resistance generally in the business to do that because everybody wants to forecast for every number. But we think this is the best thing to do in these situations.
Yeah, and there is, there is an approach you can use that applies well as well. And there was a question in the chat about low demand, highly intermittent items. What do you do? One is your forecast metrics they deal horribly with zeros. When you're talking, about measuring error against a zero, it skews the calculations significantly. The approach to use, both in terms of forecasting and analysis, generally speaking, is to forecast at a higher level and aggregate up to a higher level where that is possible, which does smooth out a lot of those zero periods. But ultimately, MAPE again is going to be highly susceptible to zero periods. At some point, I think a rule of thumb is roughly once at least half of the periods are zero, your optimal forecast becomes zero. You're going to be accurate more often than not with a forecast of zero, which is useless for planning and availability. So again, it does move into a field where you can calculate a mean average error, for example, which is a little bit less susceptible to those zero periods. But ultimately, in service parts and low demand, highly intermittent items, you pivot to an inventory policy approach over emphasizing forecasting.
Okay.
I was just about to say that for most of the stock keeping units on the shelves, the best forecast is zero forecast. So what does it mean? Do we just discontinue these products? So we have to be sensible about those type of products that we have to display. If we have to display them on the shelf, then we are going to display a unit and replenish when there is a sale, rather than going on and about improving the forecast accuracy of the models for them. Yeah. But exactly. I just noticed a question in the chat, which is relevant to both Anaplan and Vuelta. So the question is the software one which can integrate with other ERP systems such as SAP? If yes, can you elaborate, please?
Yeah, I'll take that one. Absolutely. A good cloud-based planning platform that could not integrate with the ERP systems would be useless. We leverage a lot of different techniques. Both Anaplan developed connectors into ERP systems or other planning and financial systems, as well as leveraging industry standard middleware, ETL tools. For example, we will bundle Informatica into our product as well. It's very common for us to coexist with the underlying executional and transactional systems, whether they're ERPs or Salesforce on the CRM side, and some of the other tools. But yeah, absolutely.
Yeah, I think that's the advantages for lots of people say, well, why don't we just use the ERP? Lots of companies are going on a journey, they're going to replace their systems. Why don't we just use the ERP for planning? And generally, it's just generally not worked very well, has it? I just don't find that many people that are that happy planning in the ERP system. And Anaplan is a platform that's built for planning. So that's a major strength on using Anaplan for planning. But I also think I kind of see Anaplan as an open source, like Sonos is for planning. So Anaplan is constantly building connectors to all of the cloud ERP systems, to all of the algorithms that come out, to all of the brains out there. So you have access to that. So it's a true platform. It's a platform to sit on top of your ERP systems or your data lakes. And it's also a platform to connect to all of the other things that you may want to use in planning.
Thank you for that.
There is one more technical question. It's about the history correction. When we were talking about history correction, this question came. It is about capacity ceiling. So is there any capability in Anaplan to handle capacity ceiling?
Yeah, absolutely. If I'm understanding the question effectively, a lot of supply chain processes are capacitated, have capacity limits, whether it's production, distribution, et cetera. You're moving there from the realm of forecasting into more traditional optimization techniques. But we do bundle optimization capabilities into the product, so we can do rough cut capacity scheduling, rough cut capacity planning, and more traditional capacitated network planning. And again, those capacity constraints can be defined by the user on the fly. So you can define all different takes on capacity within the network.
Yeah, and our apps leverage those capabilities too. So basically our apps take an event-driven approach. So we believe, or I believe strongly, that supply chain is not about producing a forecast. Supply chain planning is about managing the events, right? So we come up with a plan at the end, and what we're doing day to day is really managing events. So basically a promotion's moved, or there's a capacity shortfall, or suppliers let us down. This is the day to day. So we're constantly assessing the plan against capacity as well. So if you want to shift the promotion, as soon as you do that, we assess that, we rebalance the inventory, and we assess that against the capacities in the system. So whenever you're making a shift to the plan, it's kind of capacity check.
Okay.
Yep.
Maybe we have
one more
question, and this is a reference to Salesforce and customer relationship management we have mentioned before. So do you have any ideas about combining statistical planning and sales opportunity planning?
Yes, I could speak on that for the next hour, but I'm going to try to make it. Very concise. One is sales pipeline and sales opportunity should be an input to your consensus demand planning process, and in that sense, it's somewhat parallel to your statistical forecast. So that your consensus process should be comparing the two and considering sales overrides to the underlying forecast, where you can demonstrate, one, that there's forecast value add historically to the sales team adjusting the forecast, and where it's clear that the sales team has some sort of insight into the market that is not being captured in the data that you're using for the statistical forecast. The one exception would be in certain industries which are, make to order, engineering, project driven, where your sales funnel is your forecast, so to speak. In which case you get into more traditional techniques of looking at your order book, assigning probabilities and likelihoods to different orders coming in at different times. And considering all of those, you're really leveraging the sales opportunity funnel as your primary input to forecasting. Sometimes you supplement that with some statistical forecasts based on history, where you can perhaps predict which deals are most likely to close, predict which customers are most likely to introduce an order, even if they haven't introduced it yet. But there you're getting into things that deal more with customer behavior and propensity to buy, for example. We actually have a whole separate set of algorithms in Anaplan, which are designed around managing your sales pipeline, predicting the propensity of a deal to close, predicting the size of the deal, et cetera, which are useful for those types of industries.
Thanks, Mike. And I think that nicely ties into our event-driven approach and scenario-based approach. So for me, there's a number of things that could happen, which are scenarios, and a number of ways to respond to these things, which are also scenarios, more response scenarios and demand scenarios. And here's just an example where we have a number of opportunities in the system. We've sucked in from Salesforce.com. I have my base demand plan in blue here. I have scenario 1 on the left here, and scenario 2 on the right here. And in scenario 1, I choose to include these opportunities in the forecast. And in scenario 2, I've chosen not to include any. But if I add in some that include the 64 gig smartphone, then I can see I overlay the opportunities on top. Right. So with the click of the button, that for me is event-based planning. Turn on an opportunity, turn on a promo, turn them on and off. And immediately that scenario will be capacity checked against inventory, rough cut capacity planning downstream. And you can see immediately as you say that you want to forecast that opportunity, whether there are any downstream impacts or problems. So I guess with that, we should wrap. Just a resources slide. If you want to know more about our apps or Veralto, please visit veralto.com/supply chain. If you want to know more about Anaplan and supply chain, please visit anaplan.com. And if you want to know more about Cranfield and some teachings from Emelle, please visit cranfield.ac.uk. So it leaves me just to thank you all for joining. As you can probably tell, I really enjoyed that session. I have to be careful not to get too in the weeds or too geeky. But thanks to the great presenters or co-speakers, Emelle and Mike. And yeah, just leaves me to wrap up and say thanks everybody for your time.